time. It's a way of life. And so here we are on a Saturday night, and which is interesting because actually the session that I'm going to do here, this intro to Git and GitHub, isn't directly related to SQL, but I think it's pretty important, particularly as I've grown in my career. The more that I grow and the further I move along, the more that I've seen the importance of source control. And so with this, definitely excited about kind of sharing this stuff about Git and GitHub with you guys. So tonight again, the session is Intro to Git and GitHub. If you're looking for underwater basket weaving, that's going to be on a different night. Let's go ahead and move this forward. The real quick obligatory bio slide. My name is Mike Fall, as they had already said. I'm a Microsoft Data Platform MVP, certified solution expert, blah, blah, blah. I've been working with SQL Server pretty much since 1999, so coming up on, gosh, 20 years at this point. But lately, my big thing has been in SQL Server, PowerShell, kind of DevOps stuff. I do blog at mikefall.net. I apologize, though, I haven't really blogged this year. I've been really busy with my new job, which is working for a company called Rubrik, which we make an enterprise backup solution, and it's got actually some pretty slick SQL features. So if you're ever interested in that, or maybe your company has a need for a good enterprise backup solution, feel free to hit me up. So moving right along here, let me bring this up. Having some weirdness with PowerPoint and displaying things for advancing slides, but let's see if I can just advance it here. Oh, there we go. That'll work. So it's been funny with my, again, like I said, with my career. I have, over time, the more that I work with stuff, and the more that I work with code, and certainly working with developers, I've started to see more of this kind of importance for source control. And you've kind of heard it over the years. And DBAs, database folks, we've always been a little slow to adopt source control. And really, I'm not entirely sure why, because, we're developing code, albeit it's in the database. I mean, there's obviously some different challenges because we have to always work around the data, but a lot of these sort of developer disciplines that a lot of other folks get into, like around the .NET world and maybe even scripting worlds, we've been a little behind. And so I really wanted to put this presentation together kind of to talk about, how GitHub can be used to improve basically our lives as DBAs by helping us manage our code better. So with that, just a real quick, this is the important items here to kind of keep in mind. Why do we want to use source control? And it's just this matter of tracking our code, managing it over time. I've got my script folder, right? We all have it, but when you change it, and sometimes like I'll change my scripts and can't really remember, why did I change one thing to another? How did I do something? Why did I make a particular change? Maybe I put in a bug and I need to go back and fix it. And so it's good to have that history. Plus it gives us kind of the ability to share the code out. If we're writing these scripts, we have them source controlled. It makes it easier for us to share across to other folks even across the world, right? What I'll give you at the end of this presentation, amongst some other things, is I've got my own GitHub repo, and I usually direct people there for my PowerShell scripts. But it's a great place for me to put my code in that I can continually update and manage, but also allow other people to work with. So with that, we'll just go over a quick agenda here. I mean, we're going to start off by just talking about what is Git and GitHub. Now, what are the key concepts around this? And really, a lot of these key concepts are source control concepts, not necessarily limited to Git or GitHub. There are other source control systems out there, like Team Foundation Services, I think, the Microsoft TFS. There's Subversion, which is an long-standing version control. These all have different functionalities, and we'll see a little bit of that when we start to get in more about what's really makes GitHub unique. And then, of course, how do we use it? Moving into a demo to say, here's actually me using GitHub. And then I want to wrap up just sharing some tools and resources so that, like, as you go to start learning about Git, GitHub, using it, which I highly encourage even for your own personal scripts. You know, we'll talk about where you can learn more about this. Of course, during the presentation, obviously, you know, we've got some resources out there for you to ask questions, so feel free to ask questions, and I'll try to take pauses in there to answer them. So with that, let's get into really what is Git, what is GitHub, what's the big deal about this, where did it come from? And that's actually really the thing is this came about probably about 12 years ago by good old Linus Torvalds, Linus Torvalds, the guy who created Linux, right? And he's done a lot of other things. But he, in 2005, created this version control system called Git. And you know, why was it called Git? You know, this is actually directly taken from the, I believe, the man page from Unix for Git. But there's just a couple different descriptions of it, and you know, you can call it whatever you want, but more or less now Git is just Git. But kind of what makes it unique is it's this traditionally source control systems are centralized. You check code out, you check it back in. And while you've got it checked out, nobody else can work on it. And it was very difficult to use this across distributed teams and distributed environments. As we move forward into the day and the age of the internet, you've got development teams working across the globe on different things, different items. And so Git was developed to be more distributed, more nonlinear, allow different teams to work on different parts of the code without really interfering with each other. It is compatible with all these web protocols, so HTTP, FTP, SSH, right? Because again, we're working in the world of the internet where, you know, your software development project, people might be spread across the globe and not be in the same sort of network environment where they can check code in and out. The fast and scalable piece, yeah, that's a little bit. I mean, that's a little bit of, you know, flash and bang there. Really, it is scalable, but from the sense that it was built to be distributed. So that means there's no dependencies on kind of a central area of code. And of course, it's built in, you know, to be, because it's spread across the internet, to be cryptographic, to be secure, so that as you're moving stuff in and out, you know, you're not necessarily exposing private stuff that needs to remain private. And then GitHub itself, we're talking about Git here. Now GitHub, where does this come from? So GitHub is a web-based version of Git. You can have Git internally on your own system. You can have private repositories managed all. But back in not 2013 as it says here, but you know, several years ago they came up and they said, well, let's create this web version, basically a cloud service version of Git called GitHub. And you know, it's really exploded as far as its use. It's all obviously based on Git, but it's a little more than that, and allows people to come in and use it for free. You can create your own repositories as long as they're public. Of course, you can pay a fee and get your stuff private, and many companies do that. In fact, you know, as you can see here as the stat, back in 2013, GitHub had over 10 million repos in it, you know, both private and public. And Microsoft actually is moving a lot of their stuff in, and currently they are the largest contributor of repositories to GitHub. So that's pretty much the quick overview of what GitHub is, what Git is, where they came from. You know, really the key to keep in mind here is that this is a distributed source control system that you're going to use to manage your code. But how do we need to use it? You know, what's kind of the method of the madness here? And really this comes down to, like I said, not just GitHub or Git specific things, but more generalized source control concepts and how Git or GitHub implement.
We are currently improving an issue with your audio connection. Please stand by.
Can you guys still hear me all right? Because I just got the go-to. Hey guys, can you hear me all right?
Mike, I can hear you.
Okay. I just got a message about GoToMeeting was telling me something about improving my audio connection. So Did we hear everything okay? I had gone through the Git GitHub overview, and I was ready to talk about the source control concepts. Or is everybody on the same page here?
Yeah. I guess sometimes if they sort of detect the internet connection issue, they probably will prompt this. But we're hearing you okay.
Okay, great.
Yeah.
Well, with that, I'm going to keep moving on. Like I said, because this is really, that was just kind of the appetizer for you folks, right? To get you kind of understanding where we're coming from. But now let's actually start to get into things and talk about the actual source control concepts that we need to understand and how Git or GitHub implements them. So the first thing that we start off with when we start talking about source control around code is this idea of a repository. And really a repository is nothing more than a bucket where the code lives. You know, now in GitHub, this repository will sit up centralized in GitHub. You can pull the code down, you can push it back up. But really at the end of the day, this is, I don't want to call it the gold copy because we're going to talk about how the different copies are managed. But at the end of the day, this is where your code will live that you're going to work from, that you're going to extract it out and push it back into, pull and push from the repository. And with that, then we start to talk about, okay, what's the basic repository management? Because if my code's living in the repository, which again in GitHub is up on the web, or if you're doing Git within some sort of contained network, you know, it's going to be on those servers. But if that's where my repository lives, then how do I manage it to work on it myself? Because I'm not going to work on it directly in the repository. So what I will do is I will actually have a copy of this code down on my computer, right? So I have a local version of this repository that I've copied off of the centralized Git thing. And this is where Git starts to be a little different than your typical source control systems. Because source control systems, I would check a piece of code out and I essentially lock it on the source. Well, with Git and GitHub, I'm actually making a copy of that code, and I have a complete copy of that locally. And what I'm going to do is I'm going to pull and push my changes from that code into the central repository. So this way, this is where Git becomes a distributed system, because I'm not ever going to be like working directly with the code or pulling out only what I need. I'm working with my own copy of the code that I will be pulling and pushing into the source repository. And this is actually, then we start to talk about, okay, well, great. What does that mean then? Because obviously, if I pull a copy down and I start working with it, it's now going to be different from what's on the actual central repository. How do we handle this? How do we manage this? And this is where the concept of a merge comes into place. So what if I have this repository? Well, really, when I start working on it in this localized copy, what I want to do is basically do a difference check and merge that difference check into the central repository. So and that's in the case of a push. So let's say, for example, I've pulled the code down. I now have my local copy, and I'm going to work on it on my side. I'm going to work on it on my computer, make some changes to it. Well, when I'm done with those changes, I then need to merge them into that source repository. So that's when I do what's called a push into the central repository. And when I do that push, there's going to be basically a comparison that goes on, and Git will say, oh, okay, I see these differences that you made. I'm going to merge those in, and then we're going to mark those changes as what we call a commit. So this is how you start to see the version history, is whenever I make a bunch of changes to the code, I save those changes off as a commit, and this becomes just one like version step in the overall life cycle of this code. And what will happen is, right, is I have one, like, let's say I pull down the code and then I make a change to line 23 of, my SQL script. Whatever the change is, I'm going to then commit that into the Git history and say, okay, I've made this change on this date. And actually what Git will do is assign a hash value to that commit to say this is what represents it. And then when I go to push that back in, again, Git will look at the repository, centrally, compare it to what I'm pushing up in that commit, and then say, okay, I'm going to move the difference. It's really overwriting the difference, but that merge says, okay, I'm going to merge that in, and I still have this commit history, this overall history view of when that change was made and what it was. So this also means I can roll stuff back. And we'll see how this actually plays out in the demo itself. Now what this ends up meaning is we can have these commits going on, but then we can also have kind of the original source and what other people might be working on. Because keep in mind, we're not the only ones working with this version of the code. Many other people can be touching this code, doing merges, and we'll talk a little bit more about that. But this is where we start to get into the concept of what's called a branch. So if I have this main source of my code, where you see these blue hexagons here, right? I'm doing stuff on the code, and I've got this kind of gold copy of the code sitting out here. Well, in this second blue hexagon, this is where I check the code out and I start making my changes in the green. Well, we can still have stuff going on. Other people are doing work while things are still in this blue section on what would be considered the gold copy of the code. But I have what's called a branch. This is a separate copy of the code that I'm working on myself, that I'm making changes, and is basically independent of the main tree, right? So we have two different trees going on. Now at some point I might get done with my changes and I'm ready to merge them back into the main gold copy. And that's what we end up calling a pull request, and we'll see kind of how a pull request works in a bit. But this branching allows us to basically have multiple copies of the code that we're working on and kind of track where things are, right? At what point did we start altering the code in that historical view? Because if you think about it, each of these blue hexagons is a commit point, as well as the green hexagon. So this gives us that version history. We can work on multiple copies and eventually bring it back into that gold copy for maybe a full-on release. Now we also have the idea of what's called a fork. Now a fork's kind of like a branch, but just be aware that the fork here is a little different. And the idea of forking a code, and you probably have heard this, right, is basically with fork we're making a completely independent version of this. If I go back one slide, right, to look at the branch is a dependent copy. So when we split this off, this is actually still dependent on the main source tree, and eventually will get merged back in. But maybe if I want to work on something like independently, like make a completely independent copy, what I'm going to do is a fork where I completely clone the copy and I work on it separately. Now Git can see that these two are separate but yet related, and then if I want to do merges, I can merge across but still have this, like the blue fork and the green fork can be developed independently and in a sense are separate types of code. So maybe I like somebody's library, but they're not going to let me maybe necessarily work directly on it. I can make a copy of it, make my own library, and basically spin out its own version of that. It's a little confusing just because there is so much similarity to the branch and the forks, but the way, like I said, that I think of it is that branch is a dependent copy, the fork is an independent copy. Now what does this lead us to next? This actually starts to get into, okay, how do we manage code, and how do we manage code in working with like releases and distributed teams so that we don't start stepping on one another? Because as you could probably already figuring out, right, this can be very confusing and start to, there's all these different threads to track. And this is where I was taught the idea of the Git Triangle, where I basically, if I'm doing work on the code, I'm never going to be working on the golden source. Even if I'm making this copy local, like I'm never going to be pushing and pulling into what is, the term tends to be called upstream. Upstream is always considered to be kind of the source in Git terminology of what you can work with, or the kind of the gold master of the code. But you never want to work directly with it, because you might be stepping on somebody else's changes, and so you have to kind of manage what's the best way to work with that before you get it into the gold master, as well as bring everybody else's changes together. So this Git Triangle is really where things start to and it's a process of just saying, hey, I'm going to pull the code down locally, and then I'm going to work back and forth. That's what this these red arrows here is. I'm going to be pushing and pulling to kind of my own version of this, which is usually a branch, and the label tends to be called origin. So local's what sits on my computer, upstream is the golden source, and then origin is kind of what I work with, and it could be a fork or it could be a branch, but it's my copy of the code that I'm going to be working on until at such point in time that I'm like, okay, this code's all done, ready to go, and then you do what's called a pull request into the gold master. And this is more or less finalizing the process, saying, hey, let's bring that code back in. We're ready to quote unquote release it. And then this starts to lead into how the distributed teams are going to be working, because we're going to have upstream that basically a whole lot of people are going to be working on. And everybody's got their own, what you would call origin, or what they would be their own branch that they're going to be working on. Maybe a couple people are working on the same branch, and this sort of model will scale out to that. But really, at the end of the day, everybody's working on their own versions, and then ultimately they're going to be creating pull requests back into the primary repository. Now, what happens if, like, I'm working on a piece of code and somebody else is working on the same piece of code? Like, if I have a SQL script that I'm editing and I'm altering, and then, Susan in the next cubicle is working on the same script. I don't know about it, but then we go both to check in the same code. Well, this is where what we get the idea of what's called a merge conflict. A merge conflict is basically where, okay, we're looking at, and one of us maybe has checked in a change that somebody else is trying to check in over, and Git will recognize that and send an alert. And at this point, somebody actually has to take manual intervention to look at the two pieces of checked-in code and say, okay, what's actually worth keeping, what's not worth keeping. This isn't typically common, and particularly like the way that usually is recommended to get around it is if you're often committing stuff and you're not going long periods of time before checking code back in or committing it back to the repositories and the branches, you'll usually avoid merge conflicts. But it can happen, and you should just be aware of it. And really, all that ends up happening is you'll have to go through line by line of what has changed and edit it. But just something to be aware of. So that's really just kind of the flying at light speed of how to actually handle all the different source control concepts that we're looking at. So I've thrown a bunch of stuff at you. I'm going to take a quick pause here. Do we have any questions so far on what I've covered and what might be going on?
I don't see anybody posting it yet, but I do have a quick question.
Sure.
So all these code posted online, so it's public, right? It can be viewed publicly.
It can be. So that's the thing about GitHub, right? Is GitHub offers both private and public repositories, and we'll look more into like how this actually works as I start to move into the demo here in a bit. But really, at the end of the day, if you use a free repository, then it's going to be public, and anybody can look at it. If you're like working with a corporate environment or in a corporate account within GitHub, that can be locked in privately, and you can only you'll only allow certain accounts to see and manage the code. So it can be both public and private.
Maybe this question is for later on, but I just want to let you know. I was curious. There are a bunch of other softwares that can do version controls, such as like a TeamForge and stuff. Maybe if we have time, we can do a comparison.
So I don't really have a comparison set up, but I think kind of the key thing, and this is the interesting thing, is there have been some of these other, like TFS will actually support, it has its own model of source control, as well as it will support using Git. There's different approaches, but traditionally a lot of these other source control systems are non-distributed. And so what happens is if I want to work on a piece of code, I have to check it out. I have to go into the source control system, check it out, and then work on it and submit it. Nobody else can touch it while I'm working on it. And of course, that becomes very challenging as if you're working on a large project that a lot of other people might be working on. And that's where the scalable piece is because there's a bottleneck there that people will be limited to. GitHub does make a key distinction in that it is a distributed source control system where I don't actually, as we go through all these concepts, right, I don't actually have to check out a piece of code. If I'm working on a piece of code, I'm working on a localized copy of that nobody else is seeing. And eventually I'll merge it back in, but this way I'm not bottlenecking anybody if we have a larger software project.
Makes sense. There are a couple of questions from George.
Yeah, I'm seeing that here. I can go ahead and read them out here. Looks like we have one from, I don't know if this is the one from George, but somebody did ask, are there managers needed to review pull requests? Having tons of people updating codes seems to be another bug problems without reviews. So yes, really this is a process thing, right? And it can be very challenging because you can, in a lot of ways, it's like giving SA to everybody on the development team, right? If I open up my permissions to manage and submit pull requests to a whole bunch of people, I am running into danger of things spinning out of control and being difficult to manage. So just like any other process, just like any other security management, with managing your source control system, yeah, for merging back into what I call the upstream or the kind of what also is called the master branch, you want to make sure that you have only specific people allowed to do that. To give you an example, the company I work for, Rubric, we have our own PowerShell module out on GitHub. And it's something that we built to allow for people to work with our module or our software via PowerShell. Now, it's a community project. It's a public repository. Any number of people can go create branches, make pull requests, work on their code, work on the code, and modify it. But in order for it to come back into that master copy that we use, that we distribute out, one of the people at Rubric, and I'm one of them, we've got like 3 people at Rubric who actually have the permissions to merge the pull request. Anybody can make a pull request, but that doesn't mean the code actually goes into it. It's only until somebody actually executes the merge, and we actually have controls around that, as well as our process also. Like, for example, I can merge my own pull requests, but our process internally is that I don't do that. If I create a pull request, I will have somebody else merge it for me. And that way we get peer review, and you'll see this in GitHub. GitHub actually has a really nice way to implement code review and peer review within the system. So hopefully that answers your question. The second one here is, how does Git differ between TFS in quickly? I'm not entirely sure what that's meant. Is VSTS the same thing basically, and is there a hybrid solution with TFS, VSTS? So VSTS, Visual Studio Team Services, is basically the online version of TFS. And there's actually, I shouldn't say it's the online version of Visual Studio using source control, but it can use both the TFS model or the GitHub model. You got to pick one or the other. But you can set up Visual Studio Team Services to actually use Git and work in this process. While we're going to use GitHub here for this, I do want to build up a demo, and hopefully the next time I do this, have a version that uses the Visual Studio Team Services. But that's the difference is, there's not really a difference between VSTS and Git. It's more that VSTS will support either the TFS model, which is that centralized check code in and out, or Git, which is the distributed source control system. Hopefully that answers that question. Do we have any others that have come through? Both are from George. Oh, here we go. How does Git differ from TFS? I think I already covered that. Hopefully, any other questions? Hopefully that handles everything from everybody.
Yeah, that's pretty much all the questions for now.
Cool. So let's actually start to get into how do you use it? And, you know, because I've been talking a lot about the source control, but really I think a lot of this will become apparent when we actually get into practical use of GitHub, right? And a lot of people, so this is the weird thing for me, right? A lot of people in the community know me as the PowerShell guy, and I love command line interfaces. And so there is, at the core, Git is managed, Git and GitHub are managed using command line stuff, command line interfaces. And there's a way to do it PowerShell. You can do it from Bash. You can do it from, I think, CMD. However you want to do it, there is a lot of command line stuff. But this is, I'll be perfectly honest, one of those times that I want to actually use a GUI. Because I find using a GUI makes this a lot more palatable. I can always remember the commands and do stuff, but I like using a GUI for GitHub in order to just give me a little more visibility and make it a little easier to manage, because there's a lot of stuff to keep track of. So with that, I'd just like to actually, let's just jump into a demo and see how this all works from a practical standpoint. So I'm going to get out of that. What I'm going to use for this demo is a couple things. So we're going to start off, first off, this is Atlassian's source tree. There's a number of free GitHub clients, and I'm going to include links to this for in the resources section. But just so you're aware, this is the GUI client that I like to use. I'm also going to bring in VS Code, because I like to use this as my code editor for a lot of just general project stuff. Now you can, it doesn't matter what you're using. I mean, I've used GitHub around stuff like C# projects, SQL projects. I do stuff in Notepad, whatever works for you, right? I tend to just like to use this just kind of as a kind of catch-all for development. But you can use whatever tools you want. But then finally, we've got GitHub is a browser-based online source control system, right? So I can go ahead and do this all through the web interface, or I can at least get some of the initial stuff. And so here we are in my GitHub screen, my GitHub profile. There's just some basic stuff, right? You can see overviews. I can go into repositories and actually see a number of the repositories I've either forked or I'm working with, or I've created on my own. You know, some other things. I've got some people who follow me because they're looking at some of my repositories. But really, the meat of this is where we want to actually create a repository. So I'm going to go ahead up here. Let's just get started by, and let me bring up my notes so I know what I'm doing. So what I want to do first is create a new repository. And when I create this, all I need to do is give it a name. It needs to be unique under your account. And so I'm just going to call this GitHub demo. We could give it a description if we wanted, and then you have the option here. This goes back to that public-private, right? So I can either make this a public repo or private. If I make it private, I have to have a paid account where I'm allowed to make private. So we'll just leave this as public. And then I got a couple options here. I can initialize this with a README file, which is recommended, and we'll see why in a bit. And then I can add a software license. You know, this is more or less just, you don't have to do this, but if you're like making a public project, I tend to like to, sometimes I'll put a license in here, sometimes I won't. Actually, I usually like to use Creative Commons, but that's not listed here. But you can use one of the GNU public licenses, any of these. I'm going to leave that off. You can also use what's called a git ignore file. So the one thing to understand about source control, and as we create our source control folder, everything under it is going to be managed. But we all probably know that, particularly working with software projects, not everything we want into that folder we want to have source controlled. So you can apply stuff, this git ignore, and there's a lot of different options here. So typically what I run into is, maybe if you're working with a Visual Studio project, right, there's a lot of files that come with Visual Studio that you don't really care about source controlling. So if you create this git ignore file, it will ignore those. It won't source control it. And this is usually where I'll recommend to say, hey, you know, if you've got a Visual Studio project, create a gitignore for Visual Studio. I'm not going to create a gitignore file for us for this, but we'll just leave it with initializing with the README, making it a public. We could put in a description. Let's put in a description of SQL Saturday, VUG, and this is October 2017. You can put whatever you want. Obviously, I tend to, other people will read this, so if you want them to have an idea of what your project's all about, be descriptive. So I'm going to go ahead and say create repository. It's going to take a little bit of a moment here, and now my repository is created, but this is right now only in GitHub, and the only thing we have in here is this README file, right? We can actually, the nice thing about having a README file is normally GitHub will display what's in here, but we can also go into the code and actually look at the code specifically under GitHub readme.md. But now we want to work with it, right? Let's actually say, how do I pull this down to my local machine so I can start working with the repository, maybe adding some code to that. And this is where there's a security element to it, where I can do clone or download, right? And this is where I'm going to copy it down. And we have a couple different options. You can use HTTPS or you can use SSH. And this is where, if you're not familiar with SSH, it's just a matter of maintaining a public and a private key. And you can register these keys within GitHub itself. So I could go into my profile, create a SSH public key, add my public key in there, and then I have the private key locally. And that's actually something that SourceTree will manage to keep that authentication up. There's plenty of good tutorials and guides on how to set that up, and I tend to recommend that. But really what I want to do is copy this link here, this SSH link, and then we're going to go back to SourceTree and say, I'm going to we're going to do clone or new. This is where we're going to get our local copy. So for cloning, I'm going to go ahead and put in my repository link, and then I need to put a local path to it. And I want to put this actually under C, Git repositories. We're going to go GitHub-demo. Select folder. It doesn't exist, so I need to create it. So I'm just going to really quick create a new folder called GitHub-demo. We will select that, select folder. We've got a name of it. And then really at this point, all we need to do is say clone. And it's going to actually start running the Git commands to process down. Now you'll see we actually have the GitHub demos in the tab here now, and we actually have some stuff here showing us where we're working. We have the master branch. If we look on the branch, we can start. This is actually a graphical view of our history, of all our commits. You'll see we have our initial commit. It's the master branch, origin and head, so on and so forth. And we can actually come down here and see what's in the GitHub demo file, right? So let's actually, what we want to do now is let's actually start to talk about doing some source management. So I'm going to go back to Visual Studio Code. We'll get to this script here in a moment, but what I want to do is open a file. Actually, I'm going to actually open a folder. Let's open the folder, because this is one of the nice things about Visual Studio Code, is I can go into GitHub, Git repositories, GitHub demo. Let me make sure. Yep, got to go back one. So we're going to open up GitHub demo, and this will actually open up the entire folder. You can see that I've got welcome screen in my editor. We're going to close this. I'll close the welcome screen, but I can actually see all my files in here. And I'm going to open up the README, and now we've got our README file. We can start editing it just like we would edit some code. So let's say, hello world. This is Mike. So we're going to do this, and we're going to save this. Now we've saved the change, and this is kind of our working copy locally, right? But we haven't done anything yet to actually get this into the repository. So now if we go back to SourceTree, what you're going to see here is if we look at the working copy for files, it will update here. Now you're going to see that we have two sections here, staged and unstaged files. So I'm ready to commit these changes to the code, right? I'm ready. I've done my work. I'm ready to add some stuff in. So I'm going to go into this. You'll see here that the nice thing about source tree, and actually let me, give me a moment here. I'm going to fire up. I'm just thinking it might be a little hard for people to see on my monitor, so I'm firing up Zoom It. Let's see if this will allow us to get in here. Oh, that's Zoom It's going to be a pain in the butt. So my apologies, but what you're going to see here is source tree through Git is actually showing us the changes we've made to the file. But it's in an unstaged state. We're going, okay, you know, what do we do with this now? So now we can actually stage it. I'm going to say stage selected, and it moves it into the staged area. And this is saying, okay, this is going to be part of my commit. And now I'm going to go say, I'm going to say commit, but I need to give it a message. Whenever you do a commit, you actually have to put some sort of message in it to say, this is the change I made in here. So I'm going to say added a nice message. And say commit. And this updates my local copy. Now you'll see that this is again, nice thing about using the GUI, right? It says, hey, you've got one change to push up to the repository. All right, great. So I've made my change. I've committed it to the repository. But remember, we're only working with the local. We haven't merged this into our tree at the end there. So I'm going to go ahead and say push. It's going to ask me, okay, I'm going to push this back to the repository. Now this is labeled origin. This is just the default of working with it, but this is our gold copy. So say, do you want to merge that into the master branch, which is the gold branch of the code? You know, for this example, sure. So we're going to say push. It's going to run some Git commands here, which we can actually see using the full output, right? But we'll say close, and now we're going to go back to GitHub here. We're going to do a quick refresh, and now we start to see, hey, look, there's our README. We can see that, hey, there was a commit from Mike that said added a nice message, and there's our change to the README file right there. We can actually go into our commits here through the menu, and you'll see that we have now a history of 2 commits. You know, they have a little hash here. I can actually copy the full hash key, but I can also go into that specific commit and see the history here of what I wanted to change. Wonderful, great. So now we're actually starting to work with source control and start to check code in. Well, let's say now that I wanted to make a change, right? Or I wanted to add some files, but I don't want to, like I said, we want to use that GitHub tree methodology. So I'm going to go here now and make a branch. And the easiest way to make a branch in source tree here is just say, I want to create a branch. I'm going to create it off of the working copy parent. I could specify a commit in my history if I wanted to, but I'm going to use the existing one. And we're just going to call this Mike Dev. So this creates a branch. Now the way this works is really all the code we're working with locally is now under this branch. It's all going to be tracked in the history. But when we go to merge it, it will be a separate copy. You'll see how this all plays out as I walk through the demo. But now if I look under branches, right, I've got the branches here that I can work between. So what I want to do now is I'm going to go back to Visual Studio Code. First off, I'm going to create a new file, and we're going to call this hello world.ps1 because I like to do PowerShell. So we've done this, and now we're going to put some stuff into this. So there we go. I've added my code. You can actually zoom it in. You know, it doesn't really matter so much, but I'm going to go ahead and save that code. And now I'm going to go ahead and let's go back to this. Now you should always try and commit as frequently as possible. But now if I go to my file status, you see, okay, first off in the tree I've got uncommitted changes, and I can see my changes down here. So I'm going to go here, I'm going to stage my file, and it's now in here. If I actually go to the working copy, we'll see that same screen where I have the file, I have what is added to the file, so I can see very specifically the code that I'm altering. And then I'm going to say, okay, let's call this added hello world.ps1. And we'll say commit. And now we've actually added stuff. And if we go back to our branches, you'll see here that I've added this, but we're still working under the existing branch. Now let's say, for example, now like, okay, wait, I wanted to add something to that. You know, maybe I needed to do some sort of other change here. Maybe add a comment. Let's add something up here as a comment saying written, you know, some sort of code header, say written by MSF on October, what is today? Today's the 14th, 2017, right? So we've made a change to our file. So we'll save that off. Now if we go back to source tree, it'll refresh here in a moment. We'll go back into the working copy. And you'll see we now have a change that goes into the unstaged section. And you can see we'll have that change added, right? So we're getting this live editing that we're going to change to. So let's go ahead and say added code header to this. And we'll stage that. And now we're going to commit this. So we're going to make another commit. So we're building out this version history. Cool. So now if we go back to this, right, you're going to see I've got two changes here. Wonderful. So I've been working on a branch. I've made this copy locally, but now I'm ready to get it back up into the GitHub repository. So let's go ahead and say push. And now it's giving me, you'll see that it's giving me some options here of what branches to push to. Well, I'm going to push to the Mike Dev branch, which doesn't exist yet on GitHub. But this is kind of the nice thing about Git, is when I go to push these changes, it's going to actually create the branch for me. So I'm going to go ahead and say now push. I've checked off the branch that I want to merge and show the full output here. So so it's gone through here, it's created the new branch, it's updated that. Let's go back to GitHub on the web and see how do we manage this. So if we go back to the main page, you'll see, hey, recently published a branch, Mike Dev, right there, and we can do a compare and do a pull request. But you'll see now I have two branches instead of one, and we have the two commits. We're still looking at master, but now we have a drop down here where I can actually select my different branches. And if we go into Mike Dev for the branch, right now we have some different information. So GitHub's actually segmenting this all out for me. But now I can see here, oh, this looks different than master. I've got an additional file in here. It's got 4 commits. And, you know, it's actually that separate copy of the code. And now this is where that Git Triangle starts to come into play, right? Now I can actually say, let's create a pull request. I'm ready to merge this into the gold copy. I have these 2 separate copies, but now I'm going to merge this in. And so I'm going to create a pull request. And this is, again, just saying, hey, I've got code ready to merge, but we're not actually merging it. We can give the pull request a name saying, you know, new development hello world.ps1. And then we can give it a description and say, okay, hey, you know, let's say, you know, this is some new code to help us, right? Whatever we want to call it. But you'll see down here now, it's going to give me, here are all the commits in this pull request. So there's only those 2, and then there's the code that's being added. And we can say, create pull request. Now again, I'm not actually merging code yet. I'm simply setting up the code to be merged. And you know, GitHub will do some work for me to say, all right, is this already? We talked about those merge conflicts, right? So if there was a merge conflict, I wouldn't actually be able to do this merge yet, and it would give me a warning. But since everything's ready to go, it's like, oh, okay, you know, you're ready to merge this. But we, you know, typically in a software development situation, we're going to have somebody who needs to actually review this, right? Somebody who goes through the process. And this is where GitHub can be really handy. So let's say I'm coming in and I'm now somebody else. I'm like Mike Fall Part 2. And I'm going to do the review on the code. So I can go look at the commit here. I can see the different commits. But really what I want to do is go into Files Changed and see all the files. And I'm like, oh, okay, that's some good code. I see that. But maybe I want to like add something else, right? Or maybe I want to do some, some other thing. Let's actually say, why didn't you use write output, which is a different command than outpost, right? So I'm actually, what's cool about GitHub here and the whole review thing is I can actually say, add this single comment to a specific line of code, and this will notify all the other people working with this branch and this repository that, hey, something's going on, and you can come take a look at it. I can also, of course, write general comments to the entire repo. And then maybe I'll come in here and say, yeah, let me change that. However you want the whole thing, the comment to go, right? So now, okay, I'm going to have to change this to use write output instead of outhost. So let's go back to our code and come here and say, okay, instead of using outhost, I'm going to change this to do write. Actually, I think I can just pipe to it, right? So we'll just say pipe write output. And we'll save that. And again, this can be T-SQL code. This can be, Ruby code, Python, whatever you're doing in your script, right? But now I've made another change. So what do I have to do? I have to go commit that change. And if I go look at the, give this a moment, but we'll go into the working copy, let it refresh here. You'll see now I have changes. It's showing me the change here, right? So it's showing me the line that it more or less deleted and replaced it with. So we're going to stage that, and then we're going to say, hey, updating to meet code review. And then I'm going to commit this. Now again, this is all local copy right now. I've committed my change to the local copy, but now I want to push it up into the Mike Dev branch in my repository. So I'm going to say that, select Mike Dev, say push. It's going to go through and push the code. But what's nice is now I go back to GitHub, and if I now say, let's go back to the pull request and look at the pull request, you'll now see that there's another new changes, and it's versioning this out, right? So that there was a review and that there was changes since the review, and now we have a third commit here. You'll see that there are now, if we go to commits where we had 2, now we have 3. We have our message to it. So you see we're getting this versioned history of the changes we're making to the code. And if we go look here now, of course the comment went away because the line we were commenting was changed, but now everything's good. So let's say here I want to go back here and say, okay, we're good to go. I'm going to make one last comment, and there's a little icon here called Ship It Squirrel. I don't know where it came from, but this is a GitHub thing where everybody likes to use Ship It Squirrel to say ship it, the code's good. So I'm going to say ship it because we're all good here, and then I'm going to say merge pull request. And then it's going to say, okay, what's your thing here? And we'll say confirm the merge. And actually we'll now merge things and close this. So now if we go back to the master part of the branch, right? So now we're looking at the master branch, and there's our code right in it, right? And we got our README file. Everything's now part of that that master. And now if I actually say, okay, well now let's pull everything down. Let's update the local copy of this. It's got to do a quick refresh here. So I'm going to pull back from master, because right now I don't see this in master. If I actually, let's cancel that. If I go look at master, right, I don't see that hello world.ps1 that I added. Now, it's trying to get me to stage it and add it because it's on the local machine, just hasn't been added to the branch. But if I say, let's do the pull, we're going to pull the master, we'll click OK. It's going to go through the whole pull process. Everything looks good. Now we're going to close. And now, and this is where you start to see things graphically, right? So now you see where the branch, the Mike Dev branch, we're looking at master. It's showing, hey, there was this whole separate chain of work that was happening outside of master that eventually got merged in. Of course, if you have a larger project, just to kind of show you guys an example of, here's the rubric PowerShell module. where we can see some of the branches, if it'll expand to me. It's catching up here. Yeah, we'll skip it for now. Anyway, that's pretty much it, right? So we've created a branch, we've merged back into it, we've done all this cool source control stuff. Oh, Frank, so the name of this GUI tool is Atlassian Source Tree. I see your question there. Don't worry, Frank, I've got a link to this in the slide deck. You'll see it here in a bit. That's pretty much it for the demo. Hopefully you guys, I mean, there's so much further and deeper we could go into this, right? But this is to get you started. This is, again, an introduction. Hopefully this is making sense. Do we have any other questions on kind of what the demo was and how I went through it? I'm waiting to see if anything pops up in the question box.
Mike.
Oh. Yeah, go ahead.
George asked a question earlier. He said the Git client doesn't upload the code for you. I'm not sure if
let's see here. I'm looking back through here.
It's at 946.
946. I don't see that here in my window. I wonder if he sent that directly to you. But basically, so again, it depends on what Git client you're using, but really all of them should be able to perform a push up into the repository. I certainly know, like I went through and did it here with the Atlassian source tree. I've also used, there's a tool called Git extensions, and I know I've got people, friends of mine who have used the command line stuff as well. So I'm not entirely sure about your specific case, but that's one of those situations I'd have to see specifically what tool you're using. Now the question I think, Debbie, that you just sent out here is what is the purpose of staging the changes? Why does it need to be an extra step? And this is a process thing. I mean, back to the earlier question of, okay, what happens if you allow a lot of people to merge pull requests? Couldn't this get chaotic? And that's really what the purpose of staging the changes. Well, actually, wait, no, now I think about it. You're talking about staging the changes locally to create a commit. As you're working with code, all the code that you're working on at one time may not necessarily be part of a commit that you want to make. It's basically like I'm working on a file and then I'm going to save it, quote unquote, save it. So, the idea is that when you stage it, you're saying this is going to be part of this particular history and anything else that I'm working on. Now, chances are you're going to move everything you're working on into the same commit, but maybe you may not be. So it's giving you kind of that additional piece of working. Let's see here. Can automate backup dashboard to GitHub, Excel or SSMS? I'm not entirely sure what that question is asking. Can you automate? I don't know what that question is intended to be. I'm going to go here for Amanda's question. Can you link GitHub to SSMS? Absolutely. So you'll notice here I'm using Visual Studio Code as my editor, but you can use SSMS as your editor. Really, for Git, all it cares about is the file location that you're working on. So you can go in and work with a bunch of SQL files in SSMS that are saved in a particular folder, and GitHub can work with them fine. Let's see, can we download? Yeah, so so absolutely. So when I get here into the last section, Jenny, for downloading it, I'm going to give you a link to a bunch of tools. You can go create your own GitHub repos. There's a lot of instructional videos as well that you can use to get you started with GitHub. And then I think there's, sorry, go ahead.
Oh, sorry, Mike. Maybe you can send me those information so I can post it on our website.
Yes, absolutely. I will make that available to you and also show people, because guess what? I have a GitHub link where I put all my presentations. So I'll get that GitHub link out as well.
Cool. Thank you.
Yeah, so anyway, question from Steve. There seems to be a lot of tools that you have to swap in and out of. Is there anything where this can all be done in one tool to simplify things? So actually, it's funny you say that, Steve. There is actually some source control GitHub features of Visual Studio Code. Now, I'll be honest, I don't use them, but that's what this source control is here. So there's no active source control providers. I think I have to actually add it into my Visual Studio Code installation. But yeah, you can actually do your GitHub right in here. That's also why a lot of people tend to do it from the command line, because they don't have to switch in and out of tools. They just go to the command line and do stuff. Let's see here. Beverly, I came here late. You may have talked about it. Does Git go well with SSIS packages? So Git can manage SSIS packages. The one thing I will call out about SSIS packages that can make it a little challenging is the problem with SSIS, if I'm working it in the editor, if I move, it's all, so SSIS packages at the end of the day are all XML. And so it's just an XML file that I can source control. So GitHub's fine with that. The problem that you might run into is if you're working on an SSIS package, you might graphically move a box around that represents a task. And while you're not actually changing the package, GitHub recognizes that as a change, because there is a change to say, oh, this task is now located in a different part of the screen. So that's the one thing I would caution with SSIS packages is it could be very chatty as far as changes go, but you can absolutely source control it. Jenny again, can I access free online GitHub for practicing? Absolutely, yeah. Like I said, you can go create your own GitHub account. You can create your own GitHub repositories, and it's all free. Frank, do you mind demoing how to roll back to a certain point of a commit? So that's a little tricky. The way that I would typically do that is, let's say that I want to go, and I've got in here this change that I was making. Let's say that somebody came to me and said, oh, hey, I really didn't want that that hello world to be write output. I want it to be write out to outhost. So I'm just going to copy this particular change because I can see it in the history. And actually, probably the easiest, let's see, if I review, or yeah, if I reverse the lines, let's see. No, it's not reverse the lines. But I can basically come in here, identify the change. There's easier ways to basically copy it out, but I can come in here and say, oh, that's what my change is going to be, and basically back it out. Now, if you've got a bunch of changes you need to back out, there are things called rebase, or you can pull down stuff from a particular commit. That becomes a little challenging. That's why you want to be very careful about when you finally do merge stuff back in. Because the nice thing about working with a branch, right, is that's that independent copy. And if I get down a rabbit hole with the branch, I can discard the entire thing without affecting the source code. But if I want to maybe roll back one or two changes, it's just as easy to go in, find out what those changes are, and replace those back in and recommit and add those as a new commit. Because then you actually get the overall history chain of, hey, I made a change. Oh, that wasn't the right change. I rolled that change back. Wow, lots of questions coming in. All right, let's see here. Jenny, are TFS source control the same thing as GitHub source control? No, TFS and GitHub are two different ways of doing source control. Emily here, are TFS, okay, that's another, same question. TFS and GitHub are two different things, folks. GitHub is just a different way of managing it. Now, again, Visual Studio Team Services, which is kind of a lot of people relate to TFS, can do Git or TFS, but you'll have to pick one or the other. How about SSRS packages? Does GitHub work well with that? Yeah, absolutely. I can create SSRS reports. The thing about source control, guys, is you can use source control almost on anything. I use source control on PowerPoint. So that way, as I start to, like I said, I've got a GitHub that has all my presentations in it. Well, I source control my presentations and my PowerPoint. So, as I edit the slide decks, if I make a change and I didn't like it, I can always go back and look at how it used to be. So yeah, I mean, really there's no limit to what we can source control in GitHub, and it works pretty well with almost everything out there. Okay, I've gotten to the end of the questions. Are there any other questions? Oh, here we go, Emily. To prevent the password files in my location file to be shared accidentally, should I use git ignore? Yes, absolutely. If you do not store passwords in source control, guys, I can't underscore that enough. The thing about it, particularly if it goes up online and you're making it a public repository, that means anybody can see your passwords. You know, the thing about passwords is they need to be controlled in a different way. Even if you're doing internal source control where everybody has access to stuff, you still shouldn't be storing those passwords, because you're basically you can expose those passwords up to a bunch of people who probably shouldn't see it. So please, 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 please do not store passwords in source control. Let's see here. Ahaji, I do not know how GitHub is different from Bitbucket. I think they're very similar products, and they work in similar ways, but I honestly couldn't tell you what the difference is. Okay. Let's get into the... I do want to jump back into the presentation here, guys, and at least share the resources. So if you give me a second here, let me bring this back up. Let's go through the sources and tools, and then I can take any other questions that remain. So first off, as far as instruction, here's a couple links that I highly recommend to people. And first off, there's Atlassian has its own Git tutorial. Atlassian's, you know, a great company with a lot of good process flow management products. So Git tutorial, they have a good Git tutorial. GitHub has their own Git tutorial that I recommend. And then there's this great little YouTube series that I found called Git for News. And I'll definitely be able to, you'll be able to, you know, get all these links from the slide deck. Also tools, I talked about Atlassian Source Tree. That's what I use. I really, really like it. It's very clean interface. Once you start getting used to how it works, not a big deal. Git extensions is something from Google that allows you to use Git to do Git and management. And of course, there's, I mean, literally, guys, there's a ton of Git tools out there. There's probably one that, if you don't like these, one that suits your needs. So, you know, this I think goes to a link where I'll just click on the link, see if it comes up. Oh yeah, it goes to, yeah, just basically a whole bunch of different GUI options that are available to you. So with that, this has been what we covered. Hopefully, you know, you guys like are really now interested in GitHub. Obviously, we're just scratching the surface here. I've really blown through a lot of this stuff very quickly, but definitely check it out. Really, at the end of the day, the message is please use source control for your stuff, right? I have this little cliche of we're all developers now, and it really, as data professionals, it behooves us to follow good code management practices. So, you know, I like GitHub, I like Git, but if there's some other source control you like to use, go ahead and use it. It's fine. This is my contact information. I will make this presentation available. I'll get it to the organizers. But if you have questions, you can email me. There's my blog. I'm on Twitter. And of course, like I said, I've got several GitHub repos where like all my stuff is at. You're welcome to check them out. With that, I'm going to jump here real quick and answer a few of these questions before we wrap up here. So Amdow, if I have a GitHub repository, how can I control permissions to merge changes to avoid stepping on each other's code? So that's basically when you grant access, and I'll be honest, I don't do a lot of it, but if I go in here, there's a way to, let's see, settings, I think it's settings, collaborators, so you'll be able to, and I have to put in my password here, so one moment. So I can add collaborators, and when I add collaborators, I can give them different levels of permissions that either allow them or prevent them from doing merges. So this is where you would manage that. Obviously, for a personal repository like this, you know, I'm more or less going to be, people are going to be making forks, and of course, if people are making forks of my repository, I can submit pull requests across repositories, but still, because I'm the owner of this, they won't have permission to merge those pull requests. So that's where you would do that. Peter, I use Bitbucket, and they offer a free version that can be private. There is a size limit, though. So those of you guys who would like to try and use something that's free and private, check out Bitbucket. Atlassian owns it. Okay, yep. Frank, is Atlassian source tree free? Yes, it is. And then, let's see, sorry, my mic, I can't, oh, yeah, so this is from Debbie. She's saying that her mic has an issue, can't talk now, but appreciates the presentation. So I think that's it for us, guys. Sarah, are you still out there?
Yes, I'm here.
All right, I think we're good. I'm going to hang out. Let's see. Last chance for question, guys. Any questions still out there?
I guess for those people who want to use a GitHub for job hunting, would you have any advice for them?
GitHub for job hunting?
Well, yeah, well, there are people who told me they published their code on the GitHub and...
Yeah. Okay. So that's an interesting idea. That's an interesting thing that's becoming more and more popular now, right? Is certain places will want to know, and it's usually startups, to be honest, but they'll want to know what your GitHub repository is. I, of course, will share my GitHub repository on my resume, but it's kind of the same thing behind if you have a public code repository, whether it's Bitbucket or GitHub or whatever. Think about it. It's like blogging, or it's like whatever your online presence is. If you have a public GitHub repository, and you're interviewing for a job, your potential employers have an opportunity to basically see a portfolio of your work. So I definitely recommend that if you have, certainly if you have a public GitHub repository to manage your own personal scripts, share that out with in a job interview. And I'll bet you most of the guys, because I don't know too many people who do it, particularly in the DBA world, but if you share that, people are like, oh, okay, I think that's pretty impressive. And again, it's kind of like a portfolio of your work where people can see what you do and how you write code.
I suppose you have to get permission from your management before you post the code?
Well, okay, so that's just kind of a, if it's proprietary code for your company, don't go publishing that to a public location, right? Don't put code that is proprietary to your company, because that starts to get into code ownership. But any scripts that I write, like I put all my PowerShell scripts, they are generic and they don't have any sort of IP, intellectual property in them, or I mean they're my intellectual property, so I can do whatever I want with them. But that's just being a smart employee. Don't, like I said, don't put passwords out there. Don't put private code out there. Be very smart about what you're putting out there. And as I like to say, remember to wear your internet condom. Don't do stuff on the internet and share stuff on the internet that might potentially be damaging.
Yeah.
We got a couple other questions here. Somebody says, we're currently using TFS for source control. Would you recommend migrating to Git for source control, and why? I don't know that I would recommend it. I mean, I don't want to, I'm not one to come out and say, you need to change all your processes to use one thing or the other. I'm a big fan of GitHub and how it works, but to be perfectly honest, if you guys are comfortable using TFS, TFS is a fine source control system. I have some issues with it as far as the checking in and checking out and the not necessarily scalable. But at the end of the day, what works for you is what works for you. Hopefully you've seen here, the primary purpose of this is to show kind of the value of source control and use Git and GitHub as the vehicle for that. And I highly encourage that even if your company uses TFS, use GitHub try GitHub out for your own personal stuff. Let's see here. What is the advantage of using Git source control versus TFS? Again, Git is a distributed, you can have multiple people working on the same code at once and not really getting in each other's way. So that's really that. Same question here for Jujube. What is the advantage of using Git versus TFS? Let's see here. Yeah, I think that's pretty much it, guys. So Sarah, I'm just going to kick it back to you real quick to wrap up. But again, really appreciate your time tonight, guys. I'll get the resources out here, and you guys are more than welcome to hit me up if you got questions.
Cool. Thank you so much, Michael, for the great presentation. I already got quite a few feedbacks, and they really loved your presentation. And we really appreciate you taking your Saturday night to share the knowledge with us. We did learn a lot. Thank you so much. And yeah, when you share the code with and slides with me, I'll post it on our website.
Yeah, I'll get that to you probably tomorrow.
No problem. No problem. No rush.
All right.
Yeah.
Well, thanks a lot, and have a good night.
Thank you, Mike, and thank you everybody for attending. Have a good night.